Okay, so where we're going to start today is compound interest. So last class we did simple interest after the test. Then we're going to do compound interest today and effective interest rate. And that's it. It's not really 2 classes worth of material, but we'll just do that as the online video. And then the next class, when I'm back next Tuesday, we'll do ordinary annuities, and next Thursday we'll do the amortization. So we'll sort of split it up. This says today, last class today. So this sheet I gave you in class, but we'll also post it in the notes here. Okay, so I'm going to move this off to the side, but basically what we're going to do is talk about compound interest. So this is sort of more realistic interest rather than the simple interest. So the formula on any test I will be giving it, but not giving that I is equal to R over M and N is equal to M times T. So let me explain all of this. So on a test I would give you this formula, but not these. Okay, so M is the compounding periods. So what happens in the real world is usually like you'll pay something monthly or weekly or annually, and the interest is calculated on that. So say, for example, you had something that was 5%, so some kind of loan at 5%, and that would be compounded monthly. So you're going to make monthly payments. So if that's compounded monthly, then it's not 5%. It's actually your interest rate is 0.05, but it's compounded monthly. So the M is compound periods. This is the number of times per year. So if it's monthly, that's 12 times a year. So your interest rate that's used every month is 0.05 divided by 12. So 0.05 divided by 12. So your interest rate would be 0.0042. Okay, that isn't exact, so we actually don't round it off this way. What we're going to do is keep it in the calculator as this, if it doesn't work out nice. Okay, so this one, I'm just going to put a line through it. Okay, but basically the idea is it's around 0.0042, that's every month, and then it would be this in total. But that doesn't work out nice, it goes right across the screen of your calculator. Let me just show you. Actually, we might as well show you now because we'll have to do it. So do you see that that goes right across the screen? So when that happens, what we're going to do is every time we need to type it in, we're going to leave it like 0.05 divided by 12. We're not going to round it off, but you can store this. So on my calculator, there's a button right here. It says STO. Let's just write that down on the calculator. STO means store. So it's going to remember. So we'll push store. You'll see on the top it says alpha. Just look at the top there again. Whoops. Okay, so well, I stored it in Y because I pushed store. So there's a little green Y on top of the store, so I pushed store again and it saved it in Y. Let me just do that again. 0.05 divided by 12. Say you want this number, you can push store. And that little alpha comes up there and it's saying what letter do you want to store it at. And on mine they're green, A, B, C, D, E, F, X, Y, M. So you can push any of these buttons when it says alpha. So if I pushed A, so it says the answer is now stored in A. So, and then, so you hit store, and then, you know, your A, B, C, whatever letter you choose. Now, if we clear that and we needed that number again, we can push this button. It says RCL. That's recall. And so then recall, and it says alpha at the top, and saying which one do you want to recall, and I say A, and there it is. And that has kept all the decimals, even the ones you can't see. If I want to recall, I had pushed Y by mistake, so that's also in Y. If I want to recall B, I don't have anything stored there. C, D, B, F, X, Y, M. Nothing stored in any other one. Okay, so that's compounding. So how could something be compounded? It could be 12, that would be monthly. It could be 365, that would be daily. Weekly would be 52 times a year. Annually, once a year. Say quarterly. That would be 4 times a year. I could say every 4 months. There's 12 months in a year divided by 4, so that would be 3 times a year. And this one would be every 3 months. Well, there's 12 months in a year. If we divide that by 3, that's 4 times a year. Okay, so these are some different ones. They could say something else, but whatever they say, it's how many times a year. Okay, that R is your non-compounded interest rate. So that's before you divide it. And I is the compounded rate once we divide it. So you take R and you divide it by M. N is M times T. So M is the number of times it's compounded, and T is the number of years. So say, for example, we had a loan for 5 years, compounded monthly. Then your N is the number of periods in total. So N would be compounded monthly, so 12 times a year times 5 years, so 60 times. In the 5-year period, there's 60 months. So that's what that's telling us. Okay, the other numbers in the formula, so that was the I, was your interest rate compounded, so R divided by M. N is your total number of periods. P is the principal, or the start of the loan, how much you borrow. And A is the accumulated amount. Which includes interest. Okay, so let's do a few examples, and this should all come together. So we're using this formula for these next few examples. So on the sheet, the first example says, how much interest is paid on a loan of $2,500 that is borrowed at 14% per year, compounded daily? For 90 days. Okay, this is actually a good example. So again, T is time in years. So we would need to convert this to years, 14% compounded daily, and the loan amount is this. So we know that the principal of the loan, we know the interest rate that was given, it's compounded daily, that's 365 times for 90 days. That's 90 divided by 365. That's the portion of the year. So 90 days out of 365. And what do we want to know? How much interest is paid? So to calculate the interest, unlike simple interest, there's no formula for that by itself. You just fill this in. Oops. Okay, so I should have said this. I was R over M, so this divided by this. And N is M times T. So M, 365 is M times 90 divided by 365. So this actually is equal to 90. So all I need here is 90. Now why is it just 90? Well, it's every day for 90 days, so that's 90 times in total. Now we need to put this all in the calculator in 1. You can't round it off. So to do that, I would do the bracket first to the power 90. So you could do 1 plus 0.14. Oops, 1 plus 0.14 divided by 365. So that's the bracket, but don't write that answer down. And then just push y to the x. So that's right here. Y to the x. And that says your answer to what power? We want to the power 90. So that gave me the bracket, and I need to multiply it by 2,500. And now we round off because we've got our answer. So we know that A is 2587.79. Now that's not the interest, that's the accumulated amount. So the loan was for 2,500, and the accumulated value at the end, including interest, was 2587.79. So the interest is the difference between them. And that's what the question asked for, was just the interest. 2, how much should be invested to produce 1,500 in 2 years at 8% annual interest compounded quarterly? So it's wanting this as your end amount. You want to produce that. So this is your A. I is R over M. This actually works out nice when you put it in the calculator. See, it just ends. So we can just write it as 0.02. We don't need to round it or save it. And N is M times T. So 4 times 2 is 8. But now we're looking to find P. So basically this would be like, if you need to save $1,500, how much should you put in the bank now? So to produce this at the end. Always write the formula down, because if you use the right formula, you'll get marks for that. It's 0.02 to the power 8. So to solve this, this is 1,500, 1.02, 1 plus 0.02 is 1.02. You would divide. So P equals 1,500 divided by 1.02 to the power 8. Put that all in your calculator as one calculation, 1,500 divided by 1.02 to the power 8. And so P is 1280.24. Make sure you round off to the cent, so this is money. And so the question said how much should be invested. So 1280.24 should be invested to produce $1,500. Okay, number 3. A parent of a newborn wants to buy a certificate that will mature to $20,000. So that's, again, is the end, is $20,000. So that is your A, your accumulated amount, when the child turns 18. They found a savings certificate that pays 12%, compounded monthly. How much should be invested? So it's a newborn, and we want when they turn 18, so 18 years. So from here you want I is 0.12 divided by 12. If you put that in your calculator and it just ends, you can use that, which it does, is 0.01. N is M times T, so 12 times 18, 216. And we want to find P. So it's the same thing as the last question. Oops. So 20,000 N is 216. So P is 20,000 divided by 1.01 to the 216. 1 plus 0.01 is 1.01. 2331.38. Okay, not too bad. So they should invest so the parent should invest what if I said what is how much interest? Well, if they end up with 20,000 in the end, you subtract what they initially invested, then they've made a lot of interest. 17,668.62 interest. That's nice. But they left it for 18 years, so it's quite a long time to sit in the bank without touching it. Okay, so number 4 says, would you rather receive $600 now to place in a savings account earning 4% per year compounded monthly, or $900 in 10 years? Okay, so these questions where it's like a choice question, one or the other, personally, I would just say whether this is more than 900 or not, I would take the 600 now because it's guaranteed. They're going to hand it to me now. Who's to say in 10 years that won't be available? So I would take it now. But really, in math, what we're looking for is in 10 years, which one would you have more? If you put the 600 in a bank and it was saving, or if you were just given 900. So which one is more? And the one that's more is the one that we're going to answer. So there's nothing to calculate. Because that's where we're talking about. In 10 years, will 600 grow and be more than 900 or less? So we need I as R over M, so 0.04 divided by 12. I don't think that works out nice. No, it goes right across the screen, so we're not going to round it off. We'll leave it. And N is M times T, so we're saying T is 10 years, so 12 times 10 is 120. So 600 is our P, how much we're putting in the bank, 1 plus 0.04 divided by 12 to the power 120. So again, I would do that first, that calculation, that bracket, and then put it to the 120. So 1 plus 0.04 divided by 12, all to the power 120, and then times it by 600. All right, so this is less than the 900. So the conclusion should be that, it says, would you rather receive, but we'll just put it this way, 900 in 10 years is more. So that choice is better. Not by much, but it's a little better. So we would do that one. Okay, so I went rather quickly through that, but of course you can pause the video and go back and listen. You're going to try the compound interest questions. The homework actually has them all mixed together, but there's other questions online. I'm going to stop this video and then record the effective interest rate as a separate video.